the flag is up, possible redundancy, but we didn't find any. Everything's fine. False alarm. It went through. Okay. So next, we'll take an example where you actually do get redundancy and you have to deal with it. Okay, so let me put up the next example. Let me just write it here. Because we'll go to the software for the hard work. We're like masterminds and we just give orders, right? So, second example is the following. Okay. Minimize the following. Z equals to x1 plus 4, x2 plus 3, x3 plus 2, x4, just some numbers, okay, subject to the following, let me write it down, x1, 2x2, x4, 20, 2x1, x2, x3, 10, negative x1, 4x2, 2x3, 3x4, 40. Okay, let me double check all the numbers. 1, 2, 1, 20, 2, 1, 1, 10, 1, 4, 3, 40. Okay, so it's in standard form. I think this one is from the textbook, it's the same number. Yeah, didn't cook up new numbers. Okay, so you see I have 3 equations. Do I have any variable that is ready that I can use as basic variables? I don't see it, right? No column contains only one with 1. So I'll be adding 3 artificial variables, right? So artificial variables, I would add, this one will be x5, I will add an x6, I will add an x7 for these 3 equations. And I will have my w to be the sum of these 3. Okay? Would you be able to write out the new system with the artificial variables? I'm not going to do that because we can go to the LP assistance and put in the number and it will set it up automatic for us. Yeah, question?
I have a question about the previous example. Isn't that degenerate because the basic variable like x2 or x1 equals 0?
It's degenerate, but it's not redundant. That's a different question.
So is that always going to be the case if you get like a false alarm? Like if you think it's redundant and then it's not because you don't remove that equation? So
Then you have degeneracy.
it's always gonna
Yeah,
be- okay.
yeah, I think so, yeah. So degeneracy, so if your original system does not have 0 on the right-hand side, that does not mean it will stay non-zero. During the pivoting, it could become 0. Once it became 0 and this is chosen to be the one to be pivoted, and the 0 will remain there, and then you will see it. Yeah, very good question, yeah. Okay, so now, are we all excited to see our first redundancy system? Let's go to the software and let's make this problem up. Let's put it in. All right, so I'll just cover the rest so we don't have to see it. Okay, so how many equations do we have? 1, 2, 3, and 4 variables. So I need to add actually 1 regular variable. I need to add a constraint, right? So by now we shall be pros of punching in numbers, are we? We know where to put what number? If you're curious, you can put it in together with me. So let me put in these numbers. 1, 2, 0, 1, 20. That's the first equation. The second equation is 2, 1, 1, 0, 10. And the last equation was -1, 4, -2, 3, 40. Okay, and then for the z, what do I have? 1, 4, 3, 2. Did I put everything correctly? I didn't make sure it's correct, otherwise it won't get what I want. 2, 1, 1, 10. 1, 4. Okay, so that's the standard form. And I see I don't have any basic variables. Now I'm going to add artificial variables for each equation. So the first one, I add an artificial. And for the second one, I add an artificial variable. And the third one, I add as well. And this is what I get. Okay? So what is nice is it computes the equation for W automatic. Right? That's really nice. Okay, now we are ready to pivot. Okay, so looking at the coefficients for the W, I see -7 seem to be the big and negative guy. Let's pick this column. Let's check the ratio. 10, 10, 10. They're all 10. I can pick any one of them. Is that right? Shall we pick one that's not on the top? If I pick this one, the pivot will be easier, the number will be nicer. Shall we pick that one? Then don't have to see all these fractions. Let's pivot on this one. Let's try. Okay, now what do I have? Let's take a close look at all these numbers. I see that now W is driven down to 0 immediately, very quickly. And I managed to remove x6. I have x2 here, but I still have x5 and x7. They are both artificial variables, right? So I will have to get rid of them. Let's focus on x5. I want to get rid of x5. May I do that? I can pick x7 as well. And then I just need to pick one of these that is non-zero to pivot to get rid of x5. So what would you like to pick? I could pick anything. Anyone wants to? You yell a number, I'll pivot at it. Which one you want? You want to exchange x5 with what? x1, x3, or x4? x4? Well, okay, any number. It will all work. We're convinced of that. Okay, I did that. Let's take a breath and look at what we have in the next table. So the next on my list is to get rid of x7. Is that right? And I would wish to pivot on one of those 4, whichever is not 0. But they're all 0. So I can't. So what does that mean? That means one equation was redundant. I did not need one of the equation, right? So, and looking at the rest, I have all basic variables that are from the original variable. So if I just look at the first 2 equations with the right-hand side, it's in canonical form, and then the third one I will neglect. So we finished stage 1 right now. We neglect the third equation, and we start stage 2. Is that clear? Even though we leave everything there, because we can't remove it from the tableau. Okay, now I'm going to minimize z. Right now, z is 40, and I see I have a negative number here. I will look at this column, neglecting the third row, choosing between 2 and -3, then there's no choice. That's the only positive number. I will click on 2. Is that okay? Let's do that. Click on that. And now what do I have? The coefficients for z now, do I see any negative number? Nope. Which means z have reached the minimum. Is that right? The minimum value is 35. Are we able to read the tableau and figure out what to do next? Where to click? And how do you write your conclusion, where to find the answer in this tableau? So let's write out what we found. So first, we found that we found one redundancy. Is that right? So W mean is 0, so the problem is feasible. That is good. Okay. And then second, we found one redundant equation. Okay. And then we ignore that, or we remove that. Okay. And then we minimize, we did stage 2, we minimized the z. We found out the z mean. What does z mean equal to? Where do I find the z mean? Is this number, the negative of it. Is that right? Where in the table you find that. So z minimal is 35. Usually I require you to tell me where it is attained. Write out the basic solution. So you know all these yellow parts you can neglect. What's important is this, also this equation I'm neglecting, is this rectangular part is the important part. I see x1, x4 are basic variables, taking these two values, and the other two are 0. Is that clear? So x1 is 5, and x2 is 0, x4 is 0, oh no, x3 is 0, x4 is 15. Okay? Any questions? Is it clear? Let me turn on the middle center chalkboard so you see it more clearly what I wrote. Will we be able to do that? So the question usually will be find number of redundant equations. That's how you find either 0 or 1. It could be 2 if the system is large. And you need to be able to proceed after that and finish the minimization. Okay? All right. Then if no question, then that's all. Then if W mean equal to 0, okay? And then there are two situations. Okay? If no artificial variables in basic variable set. If you manage to remove all the artificial variables out of the basic variable set, then you know your original problem now is in canonical form, and you're done with stage 1. You can move on to stage 2. Is that clear? So, then you move on to stage 2. And no redundancy is needed there. Okay, you did not discover any redundancy. Okay, and now, if some artificial variables are still in the basic variable, then you need to perform this pivot process that we just described there. Okay. You need to replace it. Okay, so pivot to replace them, if possible, with this process that we talked about. Okay, and if you completed all of them, then it's still okay. You finished everything, and you can move on to stage 2. You're in canonical form and that. Okay. And then if there are redundancy, and then you have to remove those equations. So remove redundant rows, if any. Okay? Okay. And then you move on to stage 2. Okay, so you know how to do stage 2, right? So this is kind of a bigger picture, a complete simplex algorithm that it can detect non-feasible solutions will be detected here, and it can detect redundancy. After you pass through this, you will have a good canonical form linear programming problem that can be solved by the simplex method we're familiar with. Is that okay? How about some examples? We keep talking about this could happen, but we haven't seen it. So let's take an example, all right? So, example. All right. Minimize C, which is 2x1, x2, x3, x4. Subject to the following: x1 minus 2x2 plus 3x3 plus x4 is 6, negative x1, x2, 2x3. I have a fraction 2 over 3 here, 4, and like that. So we see that this is already in standard form. Is that right? It's a standard form. It's not in canonical form. And I do not detect any existing variables that I can use as a basic variable. So I will add 2 artificial variables. Is that clear? Just do that. So I will be adding 2 artificial variables, x5 to this equation and x6 to that equation. And then I will declare that W is the sum of these 2, right? And then I set up the equation for W, and I will pivot and do all that. Okay. So let's do it with the software. All right, so it takes very little time to set this up. So let's do a new problem. This is the new one. I'll just put it on top of the old one. So what do we have here? We have 2 equations and 4 unknowns. So I see that I need to add another x, right? So add a regular variable. So I will just put in the standard form. So the first equation is, if I put the numbers correct, 1, negative 2, 3, 1, and 6. Is that right? And the second equation is negative 1, 1, 2, 2 over 3. So here's how you enter a fraction. You just write 2/3, and then he knows that's a fraction. Is okay? It's very easy. And the right-hand side is 4, right? And then for the objective function, for the z, I have 2, negative 1, 1, negative 1, and the last one is 0. Is that okay? Are we comfortable? So that is the table for the standard form. And then I don't have any basic variables. I'm going to put in artificial variables. So for the first one, I add an artificial variable. Now I get the x5 there. And for the second one, I add an artificial, and I get an x6. Is that clear how I did all these? All right. Okay, so now my goal is, now I'm in stage 1. I set up the table. Now I click on pivot. I'm in stage 1. Now my goal is to drive W to 0 first. Is that right? So let's see. W has 2 negative coefficients. The negative 5 is a bigger negative 1. Let's pick this column. Is that okay? And now I need to decide 3 or 2, which one should I pivot? I look at the ratio. It's the same, 2 and 2. So pick any one. So we agree, let's just pick the one with higher position on the top, smaller index. Is it okay? Click on 3. You can click on 2, it wouldn't make any difference. Okay, I click on 3. Now, now we're in the new situation that I promised that would happen. Look at the W. It's now 0. And look at the basic variables. I still have x6, which is an artificial one, and I don't want it to be there. Is that right? So I want to move the x6 away, and replace it with anything from x1, x2, or x4. Those are all my candidates. So now this procedure we just talked about kicked in. Now I will be looking at all the coefficients in this equation. So this equation here is my equation I, the one that I talked about. And you see, as promised, the right-hand side is 0. Right? So, and I see I have 2 of them that are non-zero. I can choose any one of them. It doesn't have to be the positive one. The negative one will be fine. We'll play with both, and we'll see it doesn't matter. Okay? Let's see. We're cautious. I feel uncomfortable with the negative number. How about I try that one? Okay. Now you see, now I have W still equal to 0. Good. And I have x2, x3 as basic variables. And my original system is in canonical form. Is that clear? Now I finished stage 1. I can start stage 2. And there is no redundancy. Is that clear, the conclusion here? All right, you'll be tested on that. Now I enter stage 2, and I look at the coefficient in front of z, and I see this guy is negative. Now keep your heads cool. Which of these should I choose? I can choose only the positive one to check the ratio. Now you are in the simplex algorithm. Is that clear? Don't get confused. So I can only choose that one. Okay, I pivot there. Now you see z has only positive, non-negative coefficient, so I am done. Is that right? So from that computation that I just showed you there, I have reached the conclusion. Actually, I have 2 conclusions. First, I managed to drive W min equals to 0, and it's feasible, and I also found there's no redundancy because I managed to get rid of all artificial variables. No redundancy is found. And then second, I managed to find the z min is -6, attained at, can you find out the basic solution where the z is, the minimum is attained? So x2 and x4 will take the value on the right-hand side here. And the other x's are 0. Is that right? So x1 is 0, x2 is 0, x3 is 0, x4 is 6. Is that clear? We'll be able to do this on our own? So let's take a look. Okay, so there were a couple of places we made a choice. We could have made a different choice. Let's go back to the software. Let's go back a couple of steps. Let's remove and remove. So here, we are in the new situation that W is 0, x6 is still in the basic variable set. I want to get rid of it. Earlier, we picked 7/3 to pivot, right? Now, how about I pick this -1 to pivot? Do you think it will work? Well, just click and you'll find out. So let's click on that. And then, you see, now you have x1 and x3 as your basic variable. It looks different. Earlier we had x2, x3, right? And then original system is in canonical form. So we end stage 1 and we start stage 2. Okay, now we try to minimize z, and then I see that this guy is negative. I need to pivot further. And I see that this is only positive number here, 1/3, and I'm going to click on that. Okay, now I see I have all the z's with positive coefficient in the objective function. Do we see? Now it's positive, so z reached the minimum, right? the minimum of z is -6. So it's the same as the one I found before. Agree? But then the basic variable looks different. Now I have x1 and x4. Earlier I had, what, x2 and x4? What will be the basic solution for this one? Do you think it will be different from the one we just had? x1 will be 0. x2 and 3, 0, 0. And x4 is 6. It's the same. Do we see that? So you should reach the same conclusion because that is the unique solution here. Is that clear? Okay, so this is still an example that the situation occurs. Replace xk by xj as basic variable. Okay, if I can do that, then xk can be removed from the basic variable set, and I will have a good one into it. Okay. All right, so let's say I perform this pivot. Do you think I will risk the danger of changing the w value? W right now is 0. It's the minimum. And if I do this pivot, would I change it into bigger values? No. Would you want to comment why you think it's no?
Because the right-hand side is equal to 0. So when the W equation add the multiples of the IS equation, it's going to
You just add 0. Yeah, exactly. So that is an important observation, that we don't mess up with the W value. Do we see that? Okay, so let's put this up. So since it's important, the observation we made here, since bi equals to 0, the pivot now will not change the constant column. So in particular, what is important for us to see is w will still equal to 0 at the new basic variable after your pivot. That value won't be changed. Is that clear? All right. And now, after this, and then xk will be removed, and the xj will be in. So you remove one artificial variable in the set of basic variable. If that's the only one for you, then you're done. If that's not the only one for you, then you repeat this process for as needed. Is that clear? For all the other artificial variables that you have there. So now I will just write, now continue this process whenever possible or needed. Until all artificial variables are removed from, okay, there's a lot of writing here, from basic variable set. Okay? And if you succeeded in doing that, then you will have your basic variable will containing only the x from the original problem, and it will be in canonical form. And then you can initiate stage 2 to minimize the z. Then there's no problem, right? So if this can do, and then you would conclude no. If you manage to do it, then there's actually no redundancy. And you can move to stage 2. Okay, so that's still a favorable situation that no redundancy is ever occurred. But okay, let's say if I fail to do this, so what situation will cause me not being able to perform this procedure here? So if I cannot perform this procedure, that means I cannot find any aij in that equation that is not 0. Is that right? Which means they're all 0 there. there's nothing I can use to pivot, to replace. So this is the situation that really actually gives you redundancy. So if now I'm so unlucky in the situation, I have all these A's. Okay, it's just annoying to write these index. In algorithm, you will see all these numbers, but okay. Now, if all of these are all 0, then you cannot repeat this process, because then you don't pass that if, and you cannot do the pivot. Is that right? Then you can't do it. So what would that be? Okay, so that is where we have redundancy. Okay, then that equation is redundant. Why? So let's look at this detail. So what will we have? We'll have, what would that equation be? Well, all the x's from the original variable are now having 0 coefficient. Is that right? So I'll have 0 plus 0, all the in front of all the x from the original equation. And only those that's artificial variable, they are non-zero. And in particular, I will have this xk, which is artificial variable, and it equals to 0. That will be that equation. So all of these contains only artificial variables. And we also know w equals to 0 in the basic solution. Is that right? But if w equals to 0, we already know what we can conclude is that all artificial variables, they have to be 0 if w equals to 0. Is that right? Which is already implying that. So this equation is not telling you anything new. This equation is already implied by that. Okay? So you conclude the equation is redundant. Okay? So in principle, you would remove this equation if you are doing by hand. If you're doing in the software, well, you can't remove one line from this procedure. What you do is you just neglect that row and you continue your computation. And all the other equations now, they will be in canonical form, and you can initiate the stage 2. Is that clear? It's getting complicated. Okay, so what you do is now neglect if you are using software, and if you do it by hand, and then I will say we will remove this equation, meaning in the tableau we'll neglect this row here. Okay, and then we can move on to stage 2. Is that clear, this process? So if you have one equation, you run into this situation, then you get one redundancy. And if you shall have multiple equations that end up in this situation, then the number of redundant equations will equal to the number of this situation that you run into. Is okay? Right. Now, I want to catch your attention of one thing, just to show that this procedure is different from the regular pivoting procedure that we do in the simplex algorithm, is this thing here. So in the simplex algorithm, how did we choose which column to pivot? Well, we'll check if any of z is negative coefficient. Then we look at that column, and we find out positive A numbers. Is that right? And then we check the ratio on the right-hand side, and we try to pivot the one with the small ratio. There we require the A's to be positive to be chosen. Okay. And here, you only need this A to be non-zero. Is that clear? Because here, I am not reducing the W value because I know it's not going to change. So I only need to have one that is non-zero that I can carry out to the pivoting. My goal is to switch the basic variables between those two chosen axes. Is that okay? So pay attention. So this is different. All right? So different from what we are used to, that is Aij star has to be strictly positive to be chosen. It's different. Okay, we'll see in an example that you actually can choose one with negative coefficient. You can pivot and you can reach the goal. Is okay? So how about I write down a big summary of the complete simplex algorithm. Now we have it all, and then we'll take a look at an example. How much time do I have? Now, okay, so let's do this big summary. Okay, algorithm. Okay, so you have a problem in standard form, and you add artificial variables as needed, and then you choose the W to be the sum of them, artificial variables, okay? And you write out the correct equation for W, okay? To initiate stage 1, okay? So minimize W, okay? With the simplex. Right. And then that's in the process of all these are still in stage 1. So okay, now if I find out that W min is strictly bigger than 0, what do? Well, stop. And you conclude that the problem is not feasible. There's no solution, right? Okay. And of the other equations. Okay. And that's what we mean by redundant. So the information actually you don't need, okay? It's, remember the homework problem we did for the transport? Was it the transport? Okay, the example we took in class, the transport problem. It actually has one equation that is not needed. You can remove any one of those equations and just keep the rest, okay? So in principle, that equation should be removed from the system because you don't need it and it will mess you up in the algorithm, okay? In principle, okay? But if you have a big system with many, many equations, it's not so easy to spot which one is redundant or if it has any redundancy in it, right? So I would just say it's not easy to spot or not easy to remove either. So what we really want is the following. Okay, so I want to have some procedure that's built in my algorithm that can handle this situation. So first, it would help me to detect if a redundancy occurs, and also it will give me a clear idea of how to remove it. I want to build this in the algorithm. Okay, so that's the goal. So we want the following. We want to this whole thing here, build it in the algorithm so the first thing is to detect and then further on and remove the redundancy. Okay. So let's consider some situation which we have not seen in the examples. Something that maybe you're wondering that could happen. So consider we're doing a linear programming problem. We added artificial variables. We are performing stage 1. Okay. we're trying to drive the original system in canonical form. Okay, so let's see. So this in stage 1. Okay, you add all these artificial variables. You have a bunch of them, you add it up, and then you're doing pivoting. So the following could happen. That is, after some pivoting, you saw that W now equals to 0 at the basic variable, a basic solution for some set of basic variables. But then you look at the set of basic variable, it still contains one or more of the artificial variables that you introduced. Okay. We have not seen such things in the example because they're carefully designed not to let that happen. But that could happen, right? Okay. So let's consider that situation, all right? So, okay, so let's write this out. So after some steps of pivot, we have found that W is 0 at the basic solution, but some artificial variable remains in the basic variable. Okay, basic variable set. Okay, let's say 1 or multiple. Let's consider just 1. There is 1 there. So before we go into examples and all that, let's just think, what does it mean? What would we expect if such a thing happened? And what more we would already know before we jump into an example that this can happen. Okay? So let's say I did some pivot and I found W equal to 0, but at the equation number I, let's say, I just generically say, the ith equation that I have here would still contain a xk, which is a artificial variable. Okay? Let's say this happens. Okay. So let's write out this ith equation. So in your tableau, what would that ith equation look like? Well, on the left, you would have xk that's being labeled as the basic variable. Is that right? And then you have a bunch of things on the right. Let's just say the coefficients generically. Ith equation, the first one. Okay, let's write the equation all the way, and let's say a generic position, the ij one for xj. Okay, and there will be others, and then there will be this xk, which shall have 1 in the front because that's the basic variable right there, right? Something like that, and then you have the right-hand side. Okay. Okay, so let's analyze. So now I know that W equals to 0 at the basic solution, and I also know W is the sum of all artificial variables. If W equals to 0, what happens to all artificial variables? Last time we talked about. You sum over something that's all non-negative, and then W is 0. And then all the artificial variables must equal to 0 right there, right? Otherwise, it will be strictly positive, okay? Which means xk must equal to 0 at that basic solution. Is that right? Okay. So what is the basic solution? So the basic solution, if this is a basic variable, what will that take its value? So in the basic solution, actually should say, in the basic solution, we would have xk should exactly equal to what is on the right-hand side. Isn't that? That's how you compute your basic solution, right? All the non-basic variables will be 0. The basic variables will take the right-hand side, the constant column. Are you with me? This is, we have to gather all the information, have the whole picture in our head, and to see all these connections. Okay, so from these two sentences, what can you conclude? What will BI have to be? xk is BI, and xk must be 0. What does BI have to be? Has to be 0. There's no other way. Is that right? So you would have, before even checking, getting into the situation, now you already know if that shall happen, the BI must be 0. You must have 0 on that constant vector when this occurs. Are we okay? So that must happen. So BI is 0, and xk is still a basic variable, and w is already 0. So now this is the situation we are in. So if you run into that, okay, so flags up, that's a new situation. I will tell you now, this one now is a sign of possible redundancy. Okay, it's not for sure, you still have to further check. So it's possible now you have redundancy when this occurs. You have to do further computation to figure this out. Okay, so what can we do now? So you remember the goal for stage 1 is to, why we minimize W? Well, is to perform the pivot process so that W goes down to 0, and hopefully the original system becomes canonic. So you can initiate the stage 2 and minimize Z. Is that right? So now my W is already 0. Now I just have one goal, that is to get rid of these artificial variables in the set of basic solutions and make my original system canonical. Is that clear? That's what you want to do, right? Okay, so now that's what we want to do. Okay, so I want to find candidates in the original variable set so that I can switch it with xk. I want to pivot right there. Okay, so this is what we'll do. Okay, let me start from the top because down here you can't see. This is important. Okay, so here's the procedure we carry through. We check now if for some j, I'm checking this equation, okay, and we found that I have this number, aij. I put a star, meaning this is pivoted number, okay, that does not equal to 0. Okay, let's say this guy here is not 0 in front of xj. Okay, then what do? Whoa, so in principle, this is not 0. I could pivot here and replace xk by xj in the basic variable set. I can do that, right? There's no problem because it's not 0. I can divide by it and just move it around. Okay, so that's what we will do. So then I would pivot right there. Is it clear what I mean? So pivot, and to say that after that is artificial. All right? So let's see. Now I add -1 and 1. It gives me 0. And 0, -1 is -1. I need to flip the sign. So I get plus. Is that clear? And then 2 and 2 is 4. It shall be negative. I change the sign. And then x4, there's nothing. It doesn't, I have 0 plus 0. And then the right-hand side, I have 4 plus 4 is 8. I need to put the negative of it. So Is it clear to everyone how I got this equation? That's kind of an important step. You add up the equations where you have the artificial variables for the W. Say now, for example, hypothetically, x6 was added to equation 1 and x7 was added to equation 3, then those will be the two that you'll be adding up the coefficient and put the negative down here. Is that clear? Is it? Okay, so there are many, 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 many little steps that we're keeping adding it up, and then the whole algorithm will contain all those details. You have to remember what to do, all right? So any questions on how I get this equation? Oh, I'm sorry, W. Of course, not C. Yeah, question? Where? -1 plus 1 is -1, make it positive is plus. You have to switch the sign after you add up the coefficient. That's the process. Is that right? Is that clear? Yeah, any question? Oh, yeah. Oh, I'm sorry. There is an x5. You're right. Yeah. We will not have x4 because it's 0, 0 here, but we do have x5, right? But it's in this artificial strip. No, it is not in the artificial strip. Is it? I draw the line wrong. Sorry. The strip should be here. What is artificial is here. Over here, you don't need to put anything. Okay. Now, so what I'm going to do will be, I will cheat. Let's send everything to the software and let it compute for me. Question?
Sorry, why do you need x6 as an artificial variable?
Oh, because x5 has a -1. That is not good, right? It has to have 1 there, right? Okay, so let's use the LP assistant. Can everyone see? Is the font big enough? Okay, so let's send it in, and quickly it can do the pivoting for me. So also we will practice how to use this feature of artificial variable in the software. So what you will put in the software is you put in the standard form, okay? And then you use add artificial variable feature it will do this automatically for you, all right? So let's set it up. So I have 3 equations and how many unknowns? 5 unknowns. So I need to add a variable, 1, and add another regular variable. I need to add 2 of them, and I need to add another constraint because I have 3 equations. Is that right? Do we all know how to do this? Are we okay? So let me make it a bit bigger. The tableau goes down. And now I put in the numbers. So the first equation, what would the first equation be? 1, 2, 1. X4 is a 1, and 1. That's the first equation, right? And the second equation is -1. Is that a 2? 0. In front of x5 is -1. And the right-hand side is 4. 4. The last equation is 1, -1, 2, and 4. Okay. And then the equation for z is 1, 1, 1, and 0. Is that right? So I put in the standard form. And then I make the notice that x4 is already being used as x4 here will be the basic variable for the first equation. So I will set that in. This will take x4 as a basic variable. Is it clear? You need to be able to do this on your own, so pay attention. And now I see I need to add my artificial variables because I don't have enough basic variable. So I pick on this one, and I say add an artificial variable. And it adds the x6 for me. Do we see that? and then I take that one and I add another, and then I have the x7 for me. So what I have here now is the tableau that is the same as the one that I put up here. Okay? And the last row that is shaded is exactly the equation for W, and it's automatically computed for you. But you shall be able to write it out on your own. I will need you to know that. Is that okay? Any question how I set it up in the LP Assistant? Is it clear? Now let's go to the next step. I will pivot. So you're in stage 1. Your goal is to drive W down to 0 if possible. So you will be looking at the coefficients for this W, which is the part in this shaded yellow area, right? So I see I have a negative coefficient, -4. So this column is picked. Which one do I choose? I hover over, so the ratio here is 1, here is 2, here is 2, so the 1 will be picked. Is it clear to everyone why I pick 1? So let me click on that. I click on that, and then I get this next table. Okay, so take a look at this table. Anybody wants to comment on that? What conclusion can you make now? Let me move away the cursor. Okay, after pivot 1 step, what is the W value at the basic solution? Is the negative of that number. So W equals to 4, is that right? At the associated basic solution. And then I look at the objective function for W. Look at all the coefficients. Do I still have negative ones that I can further pivot and make W even smaller? No. So what do you conclude? What is the minimum of W for this problem? It's 4. So what do you do now? So I will write down. So by just a click, I found out that W min exactly equals to 4, which is strictly bigger than 0. I failed to drive this down to 0. What's the conclusion now? Do I need to continue and go and pivot and try to minimize Z? If W failed to reach 0, what does it mean? There are no feasible solutions for the original model. Is that right? The whole thing is not feasible. Okay, so you just conclude the original linear programming problem is not feasible. Okay, so you stop right there. So there are no solutions. That's all. Is that clear? So this process of adding artificial variables and adding this W, try to minimize W, actually will detect non-feasible problems. So you can just stop and you don't have to waste time on it. Because looking at the original problem over here, it's not easy to see that this is not feasible, isn't it? Imagine you have more equations and it's not feasible. That information is hiding. It's not easy for your eyes to see that this is not feasible. And with this process, actually, this is a bonus you get that you will know it's not feasible. Okay. If it shall be feasible, then W will be driving down to 0, and then you will initiate the second stage and solve the original problem. Is that clear? If it's unbounded below and you're meaning it's feasible, if it is feasible, if it has any feasible solutions, W will reach 0 first. The unbounded from below part you will discover in the second stage when you try to minimize the Z. Yeah, okay. Yeah, that's a good question. So is that clear? Are we okay? All right, so now we're done with the adding artificial variable part. I'll lift up the screen. All right. Now, we'll enter something that is rather complicated and probably a bit confusing. So I want to say all these examples, they are carefully made so that the procedure that we propose can be carried out without any complication. You see, we managed to reach conclusions with no problem. Actually, there's some scenario that could happen that will make it a bit more complicated, okay? So this is something we'll be focusing on today, and it takes quite some explanation. So in the textbook 3.7, that is the situation where you have redundant equations. So we call this a redundant system. Okay. So imagine you have an LP in standard form where all the constraints are equal sign. It could happen that one of the equations actually is redundant, meaning what it says, it's already been said by the other equation. So how can you find out? Okay, mathematically, how do you say that? You say that one of the equations could be expressed as a linear combination of the other equations, right? Or if you have taken 220 and you're still comfortable with it, that means the rank of that coefficient matrix is less than the number of the equations, and the right-hand side lies in the null or something, right? Okay, but let's don't use those language, just say linear combination. So it's redundant, it's already expressed by the others. So, okay, so let me put this up. So in the equation of constraints, okay, one or more is a linear combination. The midterm exam, the first midterm exam, is not too far from now. Have we been watching that date? It's not Thursday next week, but Thursday the week after. So we have about 2 weeks, right? So the original date was set to be next week. Kind of cut the semester into 3 chunks of 5 weeks for each chunk, so we can have enough material to be covered for each exam. Okay, so now it's in the 7th week, but the content of the first exam will be covering the first 5 weeks of the lecture, meaning including today's lecture. Is okay? So starting from next week, what we cover will not be in the exam 1, but will be in exam 2. Is that okay? Because otherwise exam 2 will have nothing, right? Exam 1 will be a bit overloaded. So I'm preparing a study guide, which I should load it up in Canvas maybe before this weekend, so you can take a look and think about it and practice about it. And also I am a little bit, I don't know how you feel about, do we need to have a review session, or you find that irritating, or you find that necessary? You want a review session? The Tuesday before the Thursday, but maybe not the whole class. 75 minutes a bit excessive. Maybe half of that class? Okay, we'll plan on that then. All right. Okay, so, right. Today I hope to finish up what we left last time about adding artificial variables. And then we move on to the next topic, which is actually rather confusing, so try to follow carefully. Okay, so we'll first take an example still about adding artificial variables, but the number of artificial variables you need to add is less than the number of equations, meaning you don't have to add one for every equation. Okay, so add artificial variables. Okay, so the number of that is less than the number of constraints or equations. So you will see what I mean when I set it up. Okay, so let's see. So we want to minimize the following. Okay, so we're going to take a step further. So I put up a linear programming problem. Actually, it's not even in standard form. It has inequality signs, okay? So we're going to start from there and see how to solve this, okay? And find some conclusion for this problem. So we see that these are inequalities. What do we have to do first? We need to add slack variables and change this into standard form. Is that right? So what slack variables should I add? Meaning, what should I add on the left so I can change it into equal sign? So if it's less than equal, I will be adding a slack variable. Is that right? Let's call it x4 on the left for this equation. And then the second one is bigger than equal sign, so I need to subtract something from the left so it can be equal. Is that right? Right. So all this is to make the problem in a standard form. Okay, so in the standard form, I'll have the minimize is the same. Okay, so let me copy. So minimize. It's so easy to copy the wrong number, minimizing that, and then I'll have the subject too. I'll have the following. So x1 plus 2, x2 plus x3. So for the first equation, I will add a slack. x4 on the right-hand side is 1. And for the second equation, I have negative x1, 2, x3, and I would add an x5, but negative x5, okay? And this equal 4. And the last equation is unchanged. Is that right? And then now you have all of these bigger than equal to 0. Okay, now I have it in standard form, but it's not in canonical form. I need to manipulate so that it will end up in canonical form that I can use for as a starting point for the simplex. Is that right? So we learned this trick of adding artificial variables. That's what we will do. We will add artificial variables. The goal is to make the new one with the artificial variable in canonical form, so the artificial variable will serve as the basic variable. Is that right? So now let's take a look at the standard form. I do not want to add too many artificial variables. If I already have good candidate that I can use as basic variables, I will use that. So remember earlier we had this example of changing a linear programming problem into standard form by adding slack variables, and we found out that in some cases it automatically ends up in a canonical form. In particular, remember if we have less than equal sign, right? And then we add a slack variable, and that one can be used as the basic variable. Remember? So, and we have a similar situation here, but only for this one, right? For this variable that you add. You see that this one has coefficient 1, and looking into that column, that's the only one, not in any other equation. So this can be, this can serve as a basic variable. Is that right? Which means you don't need to add another artificial variable for the first equation to use it again as basic variable. So I need to only add 2, so 2 artificial variables. I would add one for the second equation and one for the third equation. So I will be using x6 and x7. Okay? So let's see. Add artificial variables x6 and x7. Okay? They're all bigger than 0. And I would introduce the w to be the sum of these. Okay? Okay. And then I will rewrite now. Now this will be in some, I enter the stage 1. Let's write it up. Stage 1, I will try to minimize the w. But let's write the whole thing down in this tabular form that eventually we'll give to the software. So the first equation, I will not add anything to it. It's fine, because x4 is the basic variable here. You can circle it. And the second equation is like this. I need to add one artificial variable, which is x6. I add it there, and I copy it. Is that clear? Okay, so the last one, and I need to add also an artificial variable, x7, 4. So these 3 are my constraints, okay? And I would put the equation for z also in here. So z would be x1 plus x2 plus x3 equals 0 plus z. I write it like this because you know the 0 would enter the tableau. Is that okay? And then I need the equation for w. Is that right? Right now, w is set to be the sum of the artificial variable, x6 and x7. And you know, in a canonical form, w has to be expressed in terms of the non-basic one, meaning x1, x2, x3, and x5. Is that right? So how do I write the equation for w? Well, you can see that using the second equation, I can write x6 in terms of the other non-basic one, right? And I can write x7 in terms of the other non-basic variables by using the third equation. In principle, I can plug it in and expand and collect like terms and work it out. Is that right? That's an obvious thing. But last time we made this observation that is a more convenient way will be looking at the 2 equations that are involved, and then I just add them up. Is that right? So I will be adding up the coefficients, putting them down the negative of that number. Okay? And 2 for the w. So is it clear? So I want to make it very important. How do you obtain this equation for w? Okay? You take the 2 equations where you add the 2 artificial variables, and then you add the coefficients up. Is that clear? Okay, so let's draw a dotted line.